Hi class, welcome to lesson 42. In this lesson, you will be able to determine the type of chemical reaction, differentiate between synthesis, decomposition, and combustion reactions, identify missing reactants in products and balance chemical reactions, and identify products of a combustion reaction. Let's get started. There are 5 major types of chemical reactions, and 4 of the 5 types we are using elements marked as elements A, B, C, and D. These do not represent any actual elements, but could represent any element from our periodic table. A synthesis reaction is formed when a bond is made. In all synthesis reactions, there are more substances on the reactant side than as the product side, as a bond is formed between substances. Decomposition reactions are the exact opposite of synthesis reactions. In a decomposition reaction, bonds are broken, so substances are pulled apart, so there are more products than reactants. Combustion reactions are also known as burning. In combustion reactions, we are going to begin with an organic compound containing at least carbon and hydrogen, and we're going to react it with oxygen. The products of all combustion reactions are carbon dioxide and water. There are 2 other types of chemical reactions called single replacement and double replacement reactions. Today, we are only going to focus on the first 3 types of reactions: synthesis, decomposition, and combustion. Our next lesson will focus on replacement reactions.
Remember that a chemical reaction is a rearrangement of elements in the reactants before the arrow to form new substances in the products after the arrow. New substances will always have new properties. We learned back in Term 1 that there are 5 major signs that indicate if a chemical change has occurred. The only way to truly verify if a chemical change has occurred is to test the new substance to see if it has new properties. This is what we've been doing in lab lately as we've tested carbon dioxide gas, oxygen gas, and hydrogen gas for new properties, particularly for a different reaction with fire.
Synthesis reactions are reactions that form bonds. In a synthesis reaction, we'll always have more reactants than products, as the reactants will bond to form products. A very simple explanation of a synthesis reaction are when iron and sulfur bond to form iron 2 sulfide. Recall that the Roman numeral after the metal indicates the charge of the metal in the compound. When writing compounds that are formed through synthesis, it's always important to make sure that the overall charge is 0, like a stable, noble gas electron configuration.
Synthesis or combination. Here's an example. In a synthesis reaction, 2 different reactants combine to form our product. Note, the reason why hydrogen and chlorine have a 2 subscript is because they are known as being diatomic molecules. Diatomic molecules are atoms that exist in pairs. Here is a list of diatomic molecules.
In synthesis, it's often easier to write the formula in words. So when potassium and oxygen bond, they form potassium oxide. So there are a couple important points you have to remember when writing the formula using symbols. The first is to make sure that when writing symbols of diatomic elements, we include the subscripted 2 for the lone element. Notice though, when a diatomic element forms a bond, like oxygen and potassium oxide, It does not necessarily have to have a 2. The subscripts of the bonded compound are formed so that the total charge of the compound is 0. Since potassium has a +1 charge and oxygen has a -2 charge, 2 potassiums are required for every oxygen. The last step you should take when writing chemical formulas is to balance the equation. Pause the video and try and balance this equation. Here, we'll use the coefficient of 4 and 2 to balance this equation. In the next example, we have calcium, which reacts with nitrogen. Again, word equations are pretty easy, because here we're going to form calcium nitride. Now we'll write the formula equation. Remember that nitrogen is a diatomic element. We must write the formula of calcium nitride so the overall charge is 0. Remember that calcium has a +2 charge and nitrogen has a -3 charge. Now pause the video and see if you can balance the formula for the synthesis of calcium nitride. Essentially, the exact opposite of a synthesis reaction is a decomposition reaction, where bonds are broken. In decomposition reactions, you always have more products than you do reactants. So when ammonium dichromate decomposes, it produces nitrogen, water, and chromium-3 oxide. Again, we have more products. We have 3 products to the right of the arrow than reactants, 1 reactant to the left of the arrow. Take a second to look at these other examples. Potassium chloride decomposes into potassium and chlorine. Now recall that chlorine is a diatomic element and requires a subscript of 2 in the elemental state. Here we have zinc sulfide decomposes into zinc and sulfur. The most important thing to remember is to make sure that diatomic elements are followed by a subscript of 2 in their elemental state.
Now if we flip this synthesis reaction, you'll see it's now a decomposition reaction. Because in a decomposition reaction, you have one reactant that is being broken apart into multiple products.
The final type of reaction we'll talk about is a combustion reaction. Combustion reactions are also called burning. In combustion reactions, the reactants must be a hydrocarbon, a compound containing hydrogen and carbon, and it will react with oxygen gas. The products of combustion, complete combustion, are always carbon dioxide and water. You can see the general equation for a combustion reaction includes a hydrocarbon. Hydrocarbon formulas typically have carbon and then hydrogen, plus oxygen gas yields carbon dioxide and water. So in the below reaction, we have propane reacting with oxygen to produce water and carbon dioxide. Notice in a combustion reaction, energy is a product. That is because combustion is an exothermic process. Now take a minute to see if you can classify the reactions that follow.
The general equation. And here's our example, where our first reactant consists of only carbon and hydrogen. Or we can have our first reactant consisting of carbon, hydrogen, and oxygen. Your biggest clue that something is a combustion reaction is that the second reactant is O2, and our products are carbon dioxide and water. These never, ever change.
Can you classify these reactions?
This concludes lesson number 42. Make sure you've taken good notes. Write down any questions you have in your notes and bring your notes to class. Complete your homework in Google Classroom and put your reference table and calculator back in your backpack so you are prepared for class.